Question number 16 is the given graph shows the variation of volume V of a given amount of ideal gas with its absolute temperature T, right? According to this graph, the graph is passing through the origin. That means it's obey Boyle's law. V over T is equal to K, or V proportional to T, we can say, because the graph is passing through the origin, right? That means pressure is constant. There are some statements given. A, pressure of the gas at state Y is greater than that in state X, right? It's wrong actually. According to this, pressure of the gas at state Y, the pressure, let's say Py, right? According to what is given. So this is wrong, because if you want to talk about the Charles law, then pressure should be constant. So A is wrong. A is wrong in the sense the possible options are 2 or the fifth one, second one or the fifth one. We can check the rest. B, internal energy of the gas increases when the gas changes from X to Y, right? So in order to rule out that internal energies increase, what we can say, right, internal energies depend on the temperature, absolute temperature. You know, internal energy, change in internal energy is proportional to change in temperature, right? If the temperature is increased, then internal energy will also increase. So from X to Y, right, say X to Y, what is happening? X, the temperature is T1, Y, the temperature is T2, T2 is greater than T1, so the internal energy is increasing. So the statement B is internal energy of the gas increase from X to Y. That's correct. B is correct. B is correct. So among 2 and 5, B is also right. B should come. So the answer is actually C is, sorry, the fifth one is C only. So that is wrong. So answer is the second one. We don't need to check the rest. Right, if you want, you can check. C, work is done when the gas state change from X to Y. Yes, work is actually pressure into change in volume. Volume is changing from X to Y. Pressure is constant, then work is done. It's not equal to 0. So C is also correct. So B and C are correct. Option is the second one. Okay. Question number 17. A small spherical particle of mass 0. Mass is given. Mass is 0.4 kilogram. Involves to repeated collisions during a linear motion. Because of the repeated collision, right, the displacement is high at a certain instant, then displacement 0. Displacement high, it's like motion under gravity. Under gravity, right, there will be a maximum displacement. Then when the ball hit the ground back, displacement 0, like that it is given, right? Then the question is, what is the change in momentum of the particle during each collision? During each collision, what is the change in momentum? Right. If you want to find change in momentum, delta P, that is m into delta V, mass into change in velocity. Right. Here we can find the maximum velocity. Here the velocity is constant. Here, right, here negative velocity, positive velocity, negative velocity. It's like moving up. An object is moving under gravity, then thereafter, right, coming back and striking the ground. It's like that, right? So here we can find one velocity, positive velocity, say V max. This velocity will be V mini. V max we can find V max, right? The gradient of the graph 2 by 2 by 2. That will be 1 meter second minus 1. Like that, V minimum is also 1, but that will be minus, right? 0 minus 2 over 2. 0 minus 2 over this time interval 4, this is 2, 4 minus 2, that will be minus 1 meter second minus 1. So change in momentum is equal to 0.4 into change in velocity. Change in velocity is, right, initial minus final. So this will be 0.8 Newton second. The possible option is the fourth one. Right. Two particles A and B are colliding in a Cartesian plane. That means positive x direction. Right. This is the component of moment in positive x direction for A. Component of moment along the y direction for A. Right. This is before collision, and after collision is also given. Right. These two values are, right, positive in positive x direction and positive y direction, the component velocity of A before the collision. These two are the component moment of particle B in positive x direction and y direction. Like that, the after collision is also given. Right. So before collision, then after collision. Before collision and after collision, we have to use some formula, right? Right. We need to find A and B, right? Now look at this. The total x direction moment of the system before collision, that is what before collision, the total moment in the x direction will be minus 4 plus b. That will be equivalent to the, right, summation of the moment in the positive x direction after the collision, right? That means 3 plus 4. From this you can find b. B will be 11. Like that, after collision, right, after collision, the y. Before collision, after collision, you have this equate. So before collision, the y in the y direction, the moment is 5 minus 2. That will be, after the collision, the moment in the y direction will be a plus 2. It's very simple. From this you can find, this is 3 minus 2, a is equal to 1. So the answer is b is equal to 11 and a is equal to 1. The question is actually, right, it's very important, right? They are asking the b value first and a value. It's very important. B value is 11 and 1, not 1 and 11. 11 and 1 in the sense, the option is the third one. Third one is the correct option. Right. Question number 19 is comes under surface tension. There are two capillary tubes they are talking about. One is radius r. Right. One is radius r. Right. The lower end they are immersing. They are just touching the lower end to water or some. Yeah. They are. Right. When the lower end of a vertically placed pure glass capillary tube with radius r is dipped in water, m mass of water rises inside the tube, right? When they touch this lower end to the water, water is rising here, right? And the mass of the water rise on the capillary tube is r. That means the weight of the water will be mg, right? The rise is taken place. The rise of the water is taken place due to the surface tension. That means there will be a net upward force F. That will be the total surface tension. It will be 2 pi. The total circumference of the inner circle is 2 pi r. So 2 pi r into surface tension T. So what we can say, this mg is equal to 2 pi r into T. right? In the second case, what they are doing is they are just touching the end of another tube, right? We don't know the radius, but water is raised, the mass of the water raised on the tube is 2m. That means 2mg is equal to 2 pi. Let's say the radius in the second case as r dash into t. The question is r dash. So if you divide, this will be mg over 2mg half. 2 pi out, t out, r over r dash. So 2 is equal to r dash over r. R dash equal to 2r. R dash equal to 2r in the sense, the option is the third part. 4 coplanar forces of magnitude F1 and F2 acts on a single point as shown in the figure. This is the point, okay, right, in the diagram. If the magnitude of the resultant of the 4 forces is F1, then F1 over F2. The resultant is F1, right? Magnitude of the resultant is F1. In order to find this, right, we will find the component of component force, right? So if you find the horizontal component Fx, that will be, right, what, F2 cos 45. Here also F2 cos 45. 2 times F2 cos 45 is the total horizontal force acting in the left side direction, F2, right, minus this one, F1 cos 60 2 times, because here also another F1. Like that you can find the total vertical force. That will be 0. You can see, right, F1 sin 60, here F1 sin 60, equal and opposite. Like that F2 sin 45, F2 sin 45. If you want, you can write F2 sin 45 minus F2 sin 45 plus F1 sin 60 minus F1 sin 60. So total vertical force is 0. According to what is given, this resultant force is F1. That means this is 0. Only Fx is there. So Fx will be F1. Resultant force is F1. That means, what is the value? If you solve this, 2F2 cos 45 1 over root minus 2F1 cos 60 half, right? So this will be root 2 F2 minus F1 will be F1. So 2 F1 will be root 2 F2. From this you can find F1 over F2, that will be root 2 by 2, 1 over root 1 over root 2 in the sense the option number 5.